Good evening, girls. Firstly, I'd like you to check out my abs, right? Aren't those some great abbreviations that I've used there? So, it's very hard to write in pen on my iPad, as Maddie has noted and been very sympathetic towards me, so I'm going to ask you to forgive me with my judicious use of abbreviations here. Tonight I'm just going to do one example for you, and it's to use congruent triangles to prove that if a triangle has two equal sides, then the angles opposite are equal. So what does that mean? It means that if I've got a triangle and I tell you all the stuff in green, then the stuff in blue is true, right? That those two angles are equal. So let's work out how to do that. And again, I apologize, but I'm going to use quite a few abbreviations, right? So just as I've said before, there is my diagram with all the known information. I'm going to switch now to purple pen, because everything that I draw on now is going to be, what's what I'm looking for? I'm going to need to prove it. So what I'm going to do is I'm going to draw a line down here. And I'm going to label my triangle as well, actually. And I'm going to draw a line from B perpendicular to the base. Okay? Now, what I have to prove is this. But if you look at what I've got now, I've got a side pair that's equal, that also happen to be a hypotenuse. Another side that's common. I should have emphasized that I'm talking about the triangle on the left, the triangle on the right. And then I've got a right angle. So I've got my proof. I've got right angle, see, this is really painful for me. I don't want to make it too painful for you, so I'm not going to show you all the details, but I'm more than happy to put them on the board tomorrow. Right? And the reason is by construction, right? So you can actually say given there, right? You are able to draw a right angle line to another line quite easily. Number 2, AB equals BC. That is also a given, you are told that. And then the third is that the side length BD is common. So therefore we say that triangle ABD is congruent to triangle CDB, RHS. Okay, so that is my congruent triangle proof. Very brief, but you know how to flesh it out a little bit. And now it's a matter of saying, well, why are these blue lines equal? Blue angles equal? And the reason they're equal is the whole point of us proving that they're congruent is we know that congruent triangles have every single thing about them in common, right? All the angles are the same, all the sides are the same. So we can say, therefore, the angle at A, there is only one angle at A, so I can write that, equals the angle at C, and the reason is corresponding angles in congruent triangles. Okay, there shouldn't be an apostrophe there, oops. Anyway, and that means that is enough to say that they are always equal, right? And that is how we know that property of isosceles triangles. I'm more than happy to write that up in full for you tomorrow, but it is worked example 1 in your textbook. I'd like you to now go away and do worked example 2 in your textbook, please. And then, in tomorrow's lesson, we'll work through exercise 303, which is basically just more examples of this gradually getting harder, right? Using congruent triangles to prove results about special triangles and special quadrilaterals. Okay, so worked example 2 now, and I'll see you tomorrow. Thanks, girls.